Okay, good morning, Dr. Ettikan.
Hi, good morning.
Good morning, can you hear me? Okay.
Yep, I can hear you.
Okay, okay, we shall start. Okay.
Sure, go ahead.
Okay, good morning, everyone. I warmly welcome you to our third TikTok 2023, AIEIX NVIDIA. You are with me, Parinya Guntuam, or you can call me Jait. I am a moderator of today's talk. Let me tell you a little bit about our series of this TikTok. This talk will provide you with a special opportunity to get knowledge from international professionals who give you the functional language you need for real life and hands-on tasks in the technical, industrial, and scientific fields. Right now, we are delighted to bring you to our third TikTok series of 2023 on the topic of generative AI, the game changer. Our today's speaker is the Chief Technologist Director at NVIDIA Asia Pacific South region, works with NVIDIA technology adopting researchers, innovators, startups, and techno entrepreneurs to accelerate AI and TPU, DPU inclusion for the translational R&D and software development needs. He has published numerous publications and patents and developed software libraries in the past. He holds a PhD in computer science with a research focus on distributed computing and algorithm optimization. Everyone, please welcome Dr. Ettikan Kandasamy Karuppiah.
Thank you. And am I able to share my screen? I think.
Yes.
Okay, so I'm able to share screen. It's good. Thanks for giving the permission. I just wanted to make sure that share sound option is enabled. Okay. Is my screen coming through clear?
Yes.
Yeah, I just want to take this opportunity. Those who have mobile phone, you can just take out and join the GTC conference. Before I get into today's sharing, GTC is NVIDIA's world largest GPU conference that we do annually, which is a March session. And of course, we have one in September, which is the secondary GTC. The primary is always March. And we have this time 600 different talks, including generative AI, large language models. These are the key hot topics today, right? That's what I'm going to cover. So I would like to invite the student, don't limit joining only for today's session. Please join in for this March 20th to 23rd session. So we have OpenAI, we have DeepMind, all the top AI companies are presenting, including NVIDIA researchers and developers. So please do join in. I'll share the slides as well. If you don't have a camera to take a snapshot and register, it's very simple, just a couple of steps to register. It's free for you to learn, for you to join as well. I'll share the slides to the organizing team. They can actually share the slide. There's a link that you can click and register. So today I'm going to cover generative AI and its application. You know, why is it a game changer? Something that we need to look forward as an impact to the whole AI landscape. Right? I was just recently presenting in Indonesia last week. So one of the lecturer put up the hand. They said, generative AI, like, you know, ChatGPT disrupts the lecturers, because if the lecturers gives a question, students just can go to ChatGPT and find the answer and submit the report or the assignment given, because ChatGPT can generalize, right? So I said this technology is very good for the students, not good for the lecturers, right? Because lecturers have to think harder to find questions where ChatGPT cannot answer. Okay, that's why I call it a game changer. It's going to change a lot of ways that how we are doing things. So as for today, I will cover briefly neural networks and the deep learning, which is fundamental for generative AI. And then some simple workflows that we usually adopt. Let's go to, then I'll go into Gen AI. Then the challenges in terms of Gen AI and also opportunities of Gen AI. Why is it a game changer? And some example of solutions that we can look at it, right? So as you all know, I'm sure by now you are very clear about what is deep learning and neural networks. Just briefly as some history, this revolution did not start, the ChatGPT did not start yesterday, last year, 2 years ago, right? It's a long journey. Since threshold of logics by human brain was modeled by using a concept of neural networks, where you have input layer, you have a hidden layer, and then you have an output layer, right? And those who are studying deep learning or neural networks, I'm sure you've gone through the fundamentals of neural networks, right? How the summation of weights for a given activation function takes place from the node to weight that you multiply. And that is actually gone through multiple circles of innovation. Right? So this, for example, 𝐓𝐞𝐜𝐡 is another guy who actually contributed a lot in terms of statistical modeling. In terms of statistical modeling. And then we have convolutional neural networks for neocognitron developed by Professor Fukushima. Then we look at it, 1980s, recurrent neural network, RNN was founded, and so forth, right? And in early 2000, NVIDIA actually contributed for the competition called ImageNet. So that's the first time ImageNet actually leapfrogged in terms of adapting AI due to the computational capability of GPU calculating the complex model, which we'll go into. And of course, everybody knows Geoffrey Hinton. He's a godfather of the so-called new era of AI or deep learning. That's a story in a nutshell. So whatever you are experiencing today, whatever the application they can call, right? ChatGPT is one example. There are many of them. The foundation started way 60, 70 years ago, right? That's the work that's being done. And if you can see, the fundamentals are still the same. In terms of artificial neural networks, the concept is we learn from human, where there is a neuron, and then there's a nucleus, then there is an axon, which connects the link. So this is your node, and this is a weight. There is a link which connects from one point to another point, and then we try to replicate that, right, from human brain concept into what is neural networks today in terms of complexity. And that actually propagates in terms of layers, right? As simple as input layer, hidden layer, then output layer. But these layers grown complex. In a modern network, this goes into billions of parameters. I think you all would have read about different type of networks, right? So the nodes goes through billions of them. The weights also goes along with that, billions of them, and that actually demands a huge computation. So it's a mesh computation from one node to many. I mean, there's a different type of network, right? And then based on simplistic approach, it is connecting the weights nodes to a different layer, and each of these need to be calculated in parallel, right? That's where the complexity of computation comes in. Now, what GPU is great at, whatever GPU that you have, whether at home you're playing a gaming and you have RTX series or GTX series, or in school you have your DGXs. What it does is today it offloads all the complex computation of AI into GPU to parallelize, right? Once you parallelize the computation, then it becomes very fast. So the compute is very important in a nutshell. Right? So once you have the compute, next is sufficient data set. You input a lot of data set, you train the network retains some kind of a knowledge in each and every node, so that when there is an input is given, it can do a prediction, right? It can create an outcome that you're looking at. So that is how the basic fundamental of all neural networks, including a deep learning techniques that we have, it gives the result that we want. Now, let's look at roughly what is today's growth in the last 70 years, right? The number of publications are going up, including journals. Those who are doing research work and publications, how tremendous it is in terms of a number of area where deep learning being applied, whether it's a pattern recognition, machine learning, computer vision, algorithm, data mining. All the areas have seen adoption of deep learning technique to be applied rather than using traditional method of analyzing, right? For machine learning, for example, you have k-means and random forests are traditional methods, right? Gradient boosting techniques and so forth. So rather than applying those methods, people are exploring and applying deep learning based method. And that's growing into many areas, including number of patents being filed. If you see in the last 2 to 3 years, the patent filing has increased tremendously. That shows how important is this AI, not only for academicians, not only for the purpose of publishing papers, but even for industries, because very many products are being created. So as a student, as you study, as you graduate and go out, there is a lot of job opportunity will be requires you not only doing the AI engineering work, but also doing AI research, which is eventually you can publish your papers. So more examples are that, today, those who actually know ImageNet competition, if you see in the past couple of years, the capability of the neural network, whether you're looking at mask RCNN, whether you're looking at faster RCNN, or there are so many efficient NAT, and there's so many neural networks, right? Just purely on image processing. The capability of those networks has superseded human ability to do certain type of activity, right? So, human capability 95%, machines today can do almost 99%, right? So that impacts a lot of industry, autonomous vehicle, and so forth, right? Same goes to what we call question and answer. So this is fundamental for application like ChatGPT. That means ability of the neural network, the complete neural network, right? End-to-end, the model ensemble, answer questions, right? So this is, again, it didn't start 1-2 years ago, right? It has been going on for a very long time. And in fact, within the question and answer, way back 2016, people already worked on in terms of Squad. Squad is one example of algorithm, which is a deep learning based algorithm looking at question and answer, right? How do you questions, and then how does the machine able to answer the questions based on the data it has been trained, right? It's one of the method of answering questions. If you see human capability about 91% by looking at F1 score, but today, looking at specific algorithm, which is Squad 2.0, F1 score gives you almost 95% accurate. It's not 100% yet, but it gives you 95%, which is better than human. Now, same goes to hardware. NVIDIA is one of the world leading AI hardware accelerator company. And we've been putting together not 1, not 10, not 100, but thousands of them. 10,000s of those machines are put together to train the model. So, like example, there is an article that talks about how ChatGPT was trained on 10,000 NVIDIA GPUs. That's just one example. There is many companies are using NVIDIA GPUs to train many different type of models in the space, which I'll go into, right? And the cost is going down certainly for you to train the model. Way back 2017, it may cost you $1,000 to train a simple ImageNet type of a model for the competition, but today you can do it less than $5. But having said all that, I would like you to go and take a look at this report. This is published by Stanford. Stanford has done a good job in publishing this. What they have done is they collected all the journals, all the publications, all the patents, and they did a review of all these papers and publications. So take a look at this report. The source comes from there. So one of the things that they highlighted in terms of models, especially language models, right? Like BERT, Roberta, Albert, right? There is many language models. So their suggestion is, while there is huge amount of compute available because of a company like NVIDIA, who's actually building GPUs for AI, data is crucial. So, and based on the data that you train the model, right? Accuracy of the model will vary, will change, right? So one of the consideration is biasness of the model. So by default, all of us are biased, right? So like, for example, I like to eat certain type of food. I may not like some of the, I like some of the Thai food, definitely, right? They're very delicious and good, but I may not take the spiciness of Thai food. But those who are born and brought up in Thailand, they maybe adapt to the spiciness, right? So you like the spiciness because you have learned, you have been eating for a long time and you can tolerate it. But for me, maybe I'm not used to very spicy food. I can't take it. Mild spiciness, okay, right? So that's what I call, people are kind of trained in a way to adopt certain things. So similarly, there is a biasness comes in. And a model which is trained in one specific data set may not be applied to be, may not be applied directly into another area, which is quote unquote, I call inference, right? So there is a certain type of biasness the model comes with because of the data which we put in. Okay, it could be in the age-related, disability, gender bias, nationality, race, color, sexual orientation, and so forth. So the suggestion is, as you take a pre-trained model from whatever source is, you make sure that you train the model locally, right? And the model is much more adaptive to your environment, and you test and validate it. Okay, that's important in terms of the language model. And finally, of course, those who are taking these courses and learn the deep learning and AI as a fundamental, there is a job opportunity in every country. Like in Singapore, there is more jobs than people that wants to take up the job. Now, let's take a look at how deep learning use cases are being used across industries, right? Now, in this example is, let's take a question answer, right? So it could be a language model, but the language model able to do some kind of identification. You can see, ask an interesting business question. This is something where, you probably ask large language models, right? In a generative AI, you go back to generative AI, right? As you go into generative AI and you put it in, right? So you may be doing a detection, or you may be doing a classification, or you're doing a segmentation, or you are doing prediction, or you are doing recommendation. So the model that we're being built for application, like ChatGPT is actually doing all this together. So the question is it present or not? You detect, right? In the image, for example, what type of things is it? To what extent is it present, right? What extent do you think it present? So segmentation is important. So end of the day, the model is so huge because there is many type of neural networks has been ensembled together to solve a problem. That's why it becomes very complex and also trained on a lot of data set. So it can have input data, could be text, images, video, and audio, right? And then area where it is being applied, it could be healthcare, it could be retail, it could be finance, right? It can go into many areas, which will be going, I will give you some examples for Gen AI covering many of these areas. That means Gen AI will be applicable to healthcare, to retail, finance, everywhere, right? And the use cases could be for cybersecurity, could be credit scoring, for fraud detection, right? Or recommendation engine and so forth, right? So this is that's the implication. Now let's look at what is the fundamental of Gen AI. The fundamental of Gen AI is like, for example, GPT-3, one model, right, which is for question and answer type, right, which is text-based. But it's not only GPT-3, it also called DALLE, which is image-based. I'll go through some example, right? So the fundamental is the number of hyperparameters required in order to tune the model. Number of links, number of nodes is going, towards hundreds of billions. So for example, NVIDIA trained a Megatron Turing base for NLG, right? Natural language generation. It was 530 billion parameters, and we did it around 2012, right, last year. So next, we'll be sharing in coming GDC. That's what I would like to join. Even a much more complex model will be presented. So as we speak, GPT 3.5 already existed. And I read in some article, people are looking forward building the GPT-4, right? So the complexity of the models are increasing, based on transformer-based models, all right? So we see that this is a transformer-based model, the yellow color line, right? And it's growing every 2 years. Every 2 years, the growth rate is 275x. That means it almost 300 times, it gets much more complex and larger, right? Compared to other AI models. So the complexity keep increasing. That's fundamental for Gen AI. Now, what NVIDIA has done, we have taken all these Gen AI models. We have made a framework for you to train your own models, right? That means we want to democratize. So it's not only the big companies can do. Even in Thailand, there's a project from NECTEC who are looking at to train Thai language model for large language model, right? They're going to do. So you can train on your own using NVIDIA's framework. And what NVIDIA is looking at is combining not only the large language model, we also look at speech, we also look at video together, and then put that into an application. Gen AI applied for an industry use case. How does it look like? So I'll do a quick sharing a video on how this is being done. Take a look at this. I won't run the whole entire video. I just want to run a short one to give you the perception how generative AI, which is the speech component, the large language model component, question and answer capability, and then a rendering or visualization, all comes together to solve a specific problem, right? Take a look at this video, and then next we will go into detail of other components of deep learning, generative AI, okay?
I want to show you something we've been building.
Let me just...
a conversational AI, 𝐲𝐸. You're going to see speech understanding, natural language processing on the largest model ever trained, speech synthesis with my own voice, character animation, and beautiful ray trace graphics, all in real time. 𝐲𝐸 was made with some amazing technologies that have become possible only recently, and barely so. I asked a few friends to ask this cute little guy some tough questions. Let's take a look.
Hi.
Hello. Hello, Toy Jensen.
Hi, please ask me anything.
What are the greatest threats of climate change?
The greatest threats of climate change are the effects on human health, food security, water supplies, and the environment.
How do astronomers look for exoplanets?
Most exoplanets are found via the transit method. That was the case for the TRAPPIST-1 planets.
Tell me more about that method.
The transit method is when a planet passes in front of its star. The amount of light block tells astronomers the size of the planet. The duration of the transit tells astronomers the orbital period of the planet.
What telescopes use that method?
The Kepler Space Telescope used the transit method to find thousands of exoplanets.
I've heard about a satellite called TESS that is used to find planets. How does it work?
TESS is a space telescope that looks for transits.
What roles do proteins play in our cells?
Proteins are the building blocks of the body. They are the basic materials from which all living things are made. They are needed for the structure, function, and regulation of the body's tissues and organs.
How do they work?
Proteins are made up of amino acids. Amino acids are the basic building blocks of proteins. There are 20 different amino acids that link together in different combinations to form different proteins.
How do they catalyze chemical reactions?
Proteins are biological catalysts. Catalysts are substances that speed up the rate of a chemical reaction without being consumed by the...
Stop. I'm not going to run the whole video clip, but just to give you a perception how the generative AI, which is basically in this case, large language models being applied in a use case of question and answer to a Toy Jensen, right? So Toy Jensen here is able to using our Omniverse platform, able to express, share, a bit of emotion is there. So this is an industrial application of how a sample is being done, right? Okay, so having this is done last year itself, I just wanted to share with you how generative AI is actually covered. This is from a paper. So you have a machine learning techniques generally, right, which is supervised learning, unsupervised learning, and some are mixed between supervised and unsupervised, right? So that is the color actually drives this, right? So and then if you look at it, deep learning techniques, there is a deep learning, semi-supervised deep learning, unsupervised learning, and then self-supervised learning, right? So if you look at it within the deep learning, the GAN is a subset of a deep learning, right, as a whole. Okay, now let's look at what exactly the GAN is next. Now, before I get into details of GAN and share with you, today, some of the world leading companies, right, for example, NVIDIA, OpenAI, Google Research, DeepMind, and a few more, Meta, for example, are working on such large language models, right? And today it's only several companies in the world able to do this because of the compute requirement. But what NVIDIA is trying to do is we are trying to bring in the whole platform in terms of capability to train the model as a framework and make it available for you to run on a different size of GPU architecture using a framework which is NeMo Megatron, which is open. You can download today, you can use it, right? Now, briefly, if you look at this diagram, it illustrates some of the famous generative AI models. So from OpenAI, you have DALLE 2, and then they also have a jukebox. ChatGPT 3, as you know, is one example. And they also have what you call a Whisper. And from Google Research, there is a lot of work has been done in terms of, example is called Imagen, it's called Muse, Dream Fusion, Minerva, Lambda, Audio LM, and so forth, right? So Google Research has done. In terms of DeepMind, they also have quite a number of large language model, right? Which has been done as well. Meta AI has done as well. NVIDIA has done. Runaway is another company which is done using a stable diffusion, right? So there is a lot of models being built, but I tell you, this is just a tip of the iceberg. There is more models going to be built this year and coming few more years in terms of Gen AI capability, right? So one of the key feature of this model is actually called stable diffusion, which has been published anyway, and this is the fundamental in order for people to build a generative AI. I won't go into details of how stable diffusion architecture look like. I would like you to go and take a look at it and understand. But what I'm trying to share with you is think about generative AI. Not only a network model solves only text or string type. It's going to cover many different type of data set. It could be images, it could be audio, right? It could be video, and so forth, right? It's a limitless. Now, a quick summary. That what I've a quick search on the number of papers and also type of network being designed and developed by these companies will just you can actually look at stable diffusion was invented way back in August 2022, right? Which is a fundamental to build question answer type of models. But don't limit yourself to only stable diffusion or ChatGPT 3, but there are more models has been designed and developed. For example, Magic 3 from NVIDIA. And I assume the spike is going to continue. There'll be more is going to come up. Okay, and if you look at it in terms of application area, how it's being used is one is text to 3D. So given a text, a paragraph, it can create a 3D image. That's a text to 3D type of generative AI. Next is image to text. Given an image, you want a text. So for example, right, you give a portrait of maybe a nice landscape in Thailand, right? Probably in Chiang Mai area. So then you ask the network, can you write a paragraph? So it knows it's in Chiang Mai. It knows there is mountains and trees, and maybe some elephants in the picture. And it can generate a text paragraph promoting Chiang Mai. Right? That means in terms of tourism application, this can be automatically can write a paragraph knowing the background of the image by just looking at image understanding, right? The one that I shared with you, segmentation, classification, detection, all that put together, it makes a knowledge translate into a text. Similarly, text to 3D is given a paragraph, create an image. It can create an image. Similarly, it also can be applied text to audio. From the text, you create an audio. And then you can even have audio to text, listening to the audio. I mean, besides transcription, it also can do some augmentation to it, right? Next is text to text. From text, you can create another text. So for example, you have a manual. Right? Today, if you buy a device or whatever electric equipments or even online documentation of a code, you have a long manual, right? But very difficult for us to go and read the manual and understand how to operate a machine. But if I can have a ChatGPT-like application, I ask, okay, how to turn on my TV? Then it can tell. In order to turn on the TV, you look at the button at the right side of your TV, which is a model, whatever it is, it colored red color, right, with the smile inside. You just need to press. So text to text, given a large amount of text, you can create a short text to answer questions. Text to video, right? Text to code, for example, GitHub Pilot. I'll share an example where you can automatically generate a code. So a basic Python code can be created by a generative AI. So these are all examples. Now, as I shared with you, like ChatGPT is an example, Jasper.ai is another example, Adapt.ai is another example, GitHub Copilot that I shared with you is auto code generating application, right? So the underlying is the Stable Diffusion, ChatGPT, DALL-E, and many other models. Okay, if you see over here, these are the underlying models, which actually creates the on your left hand side. If you can see over here, these are the underlying models able to create all kind of application. Now the impact of this application transcends to many areas. Marketing, sales, operations, IT engineering, risk and legal, R&D activities, including drug discovery. Right? They are using generative AI. I'll share the slides with you. You can go through and take a look at it, right? And as I said, it's a game changing, right? The way it's going to transform how a lot of services being offered. How we actually able to communicate information, which can be personalized across all verticals. But just to be cautious, right? Like humans, generative AI also can make mistakes. Why does it make mistakes? Is because the data that we put in, it is not sufficient data set. We didn't train that fully, right? So there is a biasness exists. Right? So that's something which you need to look at. Then the filters are not yet enough to catch inappropriate content, right? So because you put so much of data, and for example, is being trained using, all the open source data sets available in the net, for example, right? So you still need to tune that so that some inappropriate, not locally acceptable content, culturally acceptable, may be there. So some kind of a filtering may be required, right? Based on the region's area, what is culturally acceptable, not acceptable. The biases need to be addressed. And then, if companies were to use it, it may not adopt to the company's values, company's culture, right? Company's norm. So you still need to further tune the model. For NVIDIA proposes a method called PuTune, right? Prompt tuning. So that after you take the base model, train using large data set, you still tune further so that for the type of questions being put forward and answered, you can some or other manage the outcome of the results to be persistent and following some kind of a standard that the companies may have, right? If you were to ask IP related questions, right, it may not still may not be accurate, right? So you can't rely 100% using it, but certainly it can actually help us to solve many basic fundamental work that need to be done by just using text to stacks, question and answer type of application. But I just want you to be aware of what need to be cautious. Now, okay, so if you look at it, right, if you go into the model, later I'll go a bit of zoom in into the model. It's very simple, right? So you have real data set, if you can see in the green color, right, that we put in. But at the same time, we also can put in a lot of generated data sets, right? Data set that we can artificially generate. AI itself can generate data set, or you can write your own code data set, right? So you use a real data set. You also have a human generated data set. This can be positive, this can be negative sample, right? So then there's a discriminator where it actually takes both in and trains the whole network, right? So there is a policy gradient that has been given so that how the generator actually can able to generate, right, versus the discriminator. So this is basically adversarial based text generation example, right? So take a look at this paper and how the paper suggests that AI or generative AI techniques is being applied for a text generation example, right? Okay. NVIDIA ourselves, we also have worked on many image-based type of models. That's all available in NVIDIA. Take a look at this. But this basically is an architecture how the networks looks like, right? So now take a look at another example by using a web provision of error to generate, right? So again, as I said, we are just in the beginning of generative AI. There is more models, more architecture, a different method this will be brought in by different type of researchers. And so if you look at the papers in the last couple of years, there is a lot of papers being published in Gen AI, not only specific to one area, but across many areas. I just pulled a few papers and how they are looking at the discriminator and the generator. So as I said, there's a two component, right? One is the discriminator, the other one is generator. For data set, which is real data set, also could be a fake data set to put in to train the network to become much more smarter, adapting the input which comes in. So the first one is for images. The second one is for audio, right? So this is another example how a text embedding and can concat the synthesizer. The synthesizer, if you can see, you can actually train this with the this is where the generator, which can generate some kind of information and put into the synthesizer pipeline. So in this case, could be emotional embedding, right? So how can you change the voice of you to be sad, happy, sympathize, encouraging, and so forth, right? So you can put it in and train the model. So go and take a look at so many papers are being published, right? So this is just on the left-hand side, if you can see examples of application, which is object generation using 3D models, editing for photography, right? Super resolutions, translation of clothes. So all these are examples of image-based, right? For computer vision. So this being applied. So it's not limited to computer vision. It can go into audio, it can go into video, it can go into images. So many models are being developed. Take a look at these models. So from NVIDIA perspective, we have developed a lot. We make this available. So for example, AI Toy Box is to create automatically automatic object creation. Right? For example, in this case, could be animal. A gun verse 3D is from toy box in terms of vehicles, or many other objects that can come in over here. Vehicle, just one example. And then we have audio to face, where the audio signals can be translated into facial gesture, so that when the human speaks, by just understanding the audio signals, the facial muscle expressions can be created, synthesized, just by looking at the audio signals. So audio to gesture is also trained by only looking at audio signals. We have application called Avatar Cloud Engine, uses the same techniques. We have AI Singer. There's another application done by one of our startups who are working together with us. Move.ai extension in terms of movement, predicting the movement, and also drawing the movement in terms of visualization, and so forth. There is many examples that we are creating, making it available for you to try and use it. In terms of software applications, we have adapted in terms of Maxine application, in terms of NVIDIA Canvas application, Magic 3D, Get 3D, Instant, NERF, we call it NERF. And all these models are publicly available. All these papers have been published. The software is available in a GitHub. You can download, try how the Gen AI models can be used. Now, coming back up, Gen AI is one part of the deep learning, as I shared earlier, right? How do we use it? Right? It's a simple. You take the untrained neural networks, you train with your own data set using the DGXs that you have. So the models can come, pre-trained models can come from NGC, from NVIDIA, or it could be coming from open source, for example, Hugging Face. Right? Hugging Face has a model called Bloom, B-L-O-O-M, Bloom. So Bloom actually trained in many languages. I think it's about over 50, I think 59, 60 languages they support. I'm not sure whether Thai language is part of it, might be there. So it already can support large language model trained on top of NVIDIA Megatron, will be available in coming GC. So once you train the model with your own local data set, then you can apply for an inference, for a use case. So this model that you are trying to deploy, as I said, not necessarily text-based, it could be image, it could be text to text, text to audio, audio to text, basically anything to anything. Now, so my suggestion is, as you start some of the project that you're going to work on, you can try this simply. Make sure that you get the data set, understand the data set, make sure it's clean, anonymized if you need to, because of data privacy. Get that ready, and then you get the data really prepared before you start training the data, so that you have a variety of data for a given velocity, so that you can keep training to your to train your model. Right? So data is very, very important. Now, briefly, if you look generally, deep learning challenges, including generative AI, data is always a challenge. Till today, neural network is still opaque. That means you can't do reasoning of why such an answer comes out. Given some of them experience some of the application, when you ask question A, you get an answer B, but you slightly change the question with the same intent, you get answer C, right? So that part of it is a bit inconsistent, but the way to overcome that is to do tuning, prompt tuning, so that you prompt it the answer for different type of questions still consistent. for a specific situations and scenario, right? So deep learning and context is very, very important. Contextualization of the content is very important. You need to take a look at it. Expectation of AI versus potential use cases. We need to manage expectation, right? Today, people think, oh, AI is going to become almost like a human. No, definitely not. It's a very narrow capable, right? So it is still human who is smarter than AI to train and use it for a specific purposes. It accelerates every mundane step-by-step approach, right? It can automate. That's what it's able to do today. We have production ready, production grade AI. Making it production ready, production grade is important. How we're going to deploy, how we're going to manage large scale deployment, millions of it. It's very important. In terms of the ability of the hardware to meet the performance is also critical, so that when you deploy the complex model, it's able to run efficiently, providing near real-time answers for use cases where such a response is required. For some are not really near real-time, it's okay, you can have a different architecture. So all this must be considered as you develop application to be deployed. Okay, so typically, to conclude, including Gen AI, how do you get the data, structured, unstructured, image, video, audio, all that need to be managed. Then gets into the typical training and evaluation pipeline using, for example, NeMo Megatron for large language models, but not limited to this. You can even train on DALLE or any other frameworks. Once you train, you want to go and do a production inference. So TensorRT, Triton are the frameworks that NVIDIA provides, including Gen AI, can be optimized and deployed using Triton today, right? So that it's able to be deployed. Okay, sure. Now some key takeaways. Going back as a student, understand what is deep learning, what is machine learning, what is generative AI, right? They're all different. There's many networks coming in, but the fundamental is the same. And then try to understand how the end-to-end workflow takes place. While you are the user of AI, you also must understand how the whole AI workflow works, right? Where exactly the algorithm, where is a core component, and what needs to be done in the core component. It's very important. And then also to understand what are the challenges exist and how to overcome some of the challenges, or how you can circumvent some of the challenges that the Gen AI is bringing in, either for training or inference for your specific use case. As you do your final year project, or as you're going to go to the industry and work, try to understand it, right? Okay, with that, I think I just want to stick to the 1 hour time given to me. I will stop the sharing and open for question and answers session.
Okay, thank you so much, Dr. Ettikan. Okay, now we are at the Q&A section. Okay, please feel free to drop your questions below the chat box or comment box. So let's get started. Okay, for our first question, by using generative AI, we need large data set, but if we don't need to put effort to gather a big data set, can we create more number or data from existing data sets to make sure that we have a large data set? Any suggestions? So how can we do that?
Yeah, sure. It's a good question. Certainly data set is, as I said, data is most important. So certainly you can use generators, right? Data generators, right? There's many generating tools available. So take the tools and you generate your data. But again, when you generate your data, you're making certain assumption where the data is being created. Now, the generated data goes by the assumption, but is this assumption represents the whole global truth? Or else, if you generated too much of data following certain assumption, then you are overfitting the network with whatever data that you have created, right? So you need to make sure that while the real world, real data or the truth data compensated with the generated data, which is quote unquote may be false, but not necessarily, are balanced. Okay. Yeah, nutshell, generating data sets and making it to train is common. Many tools are available. NVIDIA has a replicator is one tool that you have. You can download, you can use it for replicator. But just be cautious how you're balancing the data that you're creating, and what is your assumption as you create the data sets.
Okay, thank you. For our next question from Professor Vanida. Okay, ChatGPT benefits a great deal in many areas. However, the other side of the coin, cloud, could causes the dramatically devastation. For example, research misconduct by producing fake journal articles written by AI. So, like, is there any technology that we could reverse engineering to detect ChatGPT generation?
Yeah, it's a very good question, and it's very important.
Yes.
I think there is efforts already ongoing now called GPT-0, right? So GPT-0 is to detect the fake, differentiate what is human created and what is Gen AI created, right? There is actually, the last I read about 2 months ago, there is a lot of project globally who are creating models to detect outcome, right? That means, if let's say, for example, in the case of journal publication, right? Whether this journal was written by a deep learning GAN type of network, or generative AI type of network, or human, because based on at least the current research being done by these companies, the language model of a network, it's predictable, but humans' capability or humans' method of writing a paragraph or article is inconsistent, right? Because we don't follow a specific rule like like in a deep learning model to have the same structure of sentence. So in that perspective, it is definitely something which is we need to watch out. That's why I think I shared earlier, biasness exists. Such kind of possibility may happen, but my suggestion is two things. One is technologically, there are people actually writing algorithms to counter the I won't say fake, but I would say to counter such kind of activity, right? That's being done, so that there is a consistency between what is human created versus what is machine created. But fortunately or unfortunately, we cannot stop impact of technology. So the question is, how do we adapt and how do we manage it with cautious and also governance? I think the right word is governance. So we need some governance in place. I think Jensen, our CEO, talked about it 2 months ago. AI needs governance. So this example by Dr. Vanida is a very good example. We need governance.
Okay. Or another question. So, like, is there anything to detect the fake image, like generated by GAN?
Yeah. As I shared, there is a lot of work is going on. I read a couple of papers a few months ago. I don't know about image specific, but text specific, like a GPT-0 and a few more projects are out there to detect what is human generated and what is machine generated, including images. Do a quick search, you will find a lot of papers in this area. A lot of projects are already ongoing.
Okay, another question. So what are your thoughts on the ethical concerns surrounding generative AI, specifically regarding the use of data from platforms like Stack Overflow or GitHub to train models such as ChatGPT?
Yeah, it's a very good question. As I iterated earlier, we need to have a way to, there must be a governance. there must be a governance, right? That means we need to governs how AI going to be adopted and to be used, right? So who is going to take charge on bringing the governance? It's all of us are responsible to do that. Not only the people who create the technology, but also the people who are actually using the technology, right? So in such case, we can't stop people to create application, make it available, right? So automatic write codes, but we can look at, for example, we can look at higher order of solving problems. So like, if, let's say the tool can do auto-generate source codes, simple structure of the source codes, then we no need to, have engineers solving the auto-generation of a simple structure, right? Managing input and output, getting the format, all that can be auto-generated. But then the software engineers can use this tool to solve some of the mundane basic problems, but look at the complexity of the issue of overall problem solutioning. So that means you look at higher order issues rather than looking at low order, which is just step-by-step code writing. So we need to change. Another example that I gave is for the professors who are actually providing questions as part of your, continuous assessment, right? So today you write those questions and give it to them. They have to submit either typed version or handwritten version, after 1 or 2 weeks. So if you give a straightforward questions, they can go to ChatGPT, ask the question, get the answer, copy and paste, right? So don't ask any straightforward questions. Ask higher order thinking, much more complex questions. All right. So of course, there's more work to the lecturers or professors to think and generate new questions.
Okay. For our another question from Kun Thanapol. Okay. In my opinion, before nowadays, NLP is quite underrated. But if considering NLP AI based on the quote that say language is representation of reality, from this quote, does it mean in the future like NLP can literally do anything?
It's a very interesting quote that you have given, right? Humbly, I cannot predict the future. But what I would say is there's a lot of engineering work still required that that it can do anything, right, at this point of time. I mean, for those who have tried using a lot of these famous applications, like ChatGPT is only one. There is many companies are providing today. If you take that application, if you ask tricky questions, it cannot give you the answer that you expect it's supposed to be, right? So I don't know whether you are right or the machine is right. I leave it to you to decide. But there are people, or even I tried, I'm not happy with the answer. I think it's not correct. It doesn't mean I'm right. I may be not right. But we've been trained and we have learned many things. So we see it is not there yet. So with that space, whether with the language model capability, will NLP have a superior capability than human being? It is still area of research. I don't know whether we found the answer yet. But at this point of time, anything mundane, anything repetitive, anything can be automated. The language model with the NLP support able to solve the problem.
Okay. Thank you for the question. And thank you for your answers, Dr. Ettikan. Okay. Any questions? Oh, okay. Oh, okay. Okay. Kun 𝐸𝐴 have shared that you have 2 special sessions, right, for Thailand during GTC below Thailand GTC Watch Party session. Now you can like check out the information on our chat box. So, okay. Thank you so much. Thank you so much, Kun 𝐸𝐴 for sharing us some useful information. You can join the session on the Friday, March, and Friday, March 24th and Tuesday, March 28th นะครับ Okay. Okay, if there aren't any questions, no, thank you for all the interesting and useful questions. So I'd like to thank you, Dr. Ettikan, for today's talk very much. So we hope you to come back as our speaker again next time. So we sincerely appreciate it. You have made your wonderful presentation always. Okay, so that's it for today. And thank you, Dr. Ettikan, again. And also thank you, everyone, for attending our third TikTok 2023 AI, EIX, NVIDIA. Okay, sorry, we do have another question, Dr. Ettikan. Okay. The language models are getting really close to human way of conversating. However, lifelike robots like Sophia, which products, emotions, and hand gestures are still far behind. What can we be the possible reasons and why?
Sure, it's a very good question. I could share my opinion by reading many papers. As you can, I just was Googling for some papers in terms of generative emotions, right? There's quite a significant work being done today by some of the famous universities in having generative AI even for emotions, sorry, right? So the work is still being done, and I hope in the next few years I will see very good publications and also models being created for emotions, like either audio specific, like the paper that I shared with you, or it could be even could be visual emotions, right? So it's a lot of work to be done, but coming back, why is it not as accurate from the scientific perspective? There's not enough research has been done. I think a human is a very complex being, right? So there's a lot of things that we need to learn and understand, because the translation of AI from what we are doing, for example, of language is quite easy, because the language can be represented by by text and words and sentences and paragraph. So we can actually train by using neural networks to take this, right? But emotion, on the other hand, is very subtle. It's a tacit. So the tacit is it's difficult to be decoded. So I think the challenge that many of the researchers have today is, how do you extract the data, emotion data? So if they're able to extract the emotion data, decode it in a way that you can put it into the input of a neural network, then it'll be much easier to create networks. So the challenge is, again, as I said, data. Is acquisition of the data, making the data to be as possible generalized to cover all is important. So that's my my humble opinion, reading most of the papers, but a lot of good work is already taking shape. And I hope in the next few years, you will have good emotional AIs.
Okay, thank you. Thank you for all the questions and the interesting questions, and thank you for the humble answers for you, Dr. Ettikan. Okay, are there any questions? You can type it below in the chat box or our comment box. Okay, if there aren't any questions, now I'd like to thank you, Dr. Ettikan, again, and also thank you everyone for attending our third TikTok 2023 AIEIX NVIDIA. So we hope to see you again in the next episode. So please stay tuned. Have a nice day and goodbye. นะครับ สวัสดีครับ
สวัสดีครับ
สวัสดีครับ Thank you so much ครับ Dr. Ettikan ครับผมครับ
Thank you.